So now let's look at the second function that we have. So the second function that we have, the height of a falling marble is recorded and modeled by the equation equal negative 5x plus 2. Looking at the equation y equal negative 5x plus 2, can you tell me if this is a linear equation or not? It is. Why is it a linear equation? Degree 1. So you see that there is no x, so I know it's degree 1. Okay, now let's look at the table of value. Okay, remember that the x's in this case, they're given to you. So my x's are 0, 1, 2, 3, and 4. And then my job is to plug in the x value into the equation and solve for y. Okay, so my x is 0. So I replace x with a 0, and I have negative 5 times 0 plus 2. You guys see that? Okay, so bedmass tells me what do I have to do first? The brackets then, which I don't have anything inside the bracket. Then I have to do exponent. I don't have exponent. Then I have to do multiplication division, right? So in this case, I have the multiplication. I have to do that first. So negative 5 times 0 is 0. Add 2, 2. Now, we're going to have to do the next one together. Okay, I'm going to replace x with 1. And that's going to be negative 5 times 1 plus 2. What's negative 5 times 1? Negative 5. Add 2. Negative 3. Right? Negative 5 times 1 is negative 5. Add 2 is negative 3. I have to do the same thing here. So negative 5 times 2 is negative 10. Add 2 is negative 8. Negative 5 times 3 is negative 15. Add 2 is negative 13. Are we okay with this? Yes. Okay. Then I have negative 5 times 4, so that's negative 20. Add 2 is negative 18. Okay? So in this way, I found the y values. So I was given the x values. I plugged in the x values into the equation, and I solved for y. Are we following this? Yes. All right. Now, after I finish finding the y values, in this case, what I have to do is I have to find the first difference. To find the first difference, I have to do what? What do you have to do to find the first difference? y2, take away y1. George, move a little bit. So, what's my y2? Negative 3, right? So this is my second y value, and I'm going to subtract the first y value. Okay? So y2, take away y1. So negative 3, take away 2. What would that give me? Negative 5. Okay? So to do the first difference, I start from the bottom. I take away the upper y value. So negative 8, take away negative 3. You guys have to be careful here because there's too many negatives. Okay? So negative 8, take away negative 3. That's negative 8 plus 3. Right? Remember that this here is going to become plus because I have two negatives right after each other. So what's negative 8 take plus 3? Sorry. Negative 5. What will be my next one? Negative 13 take away negative 8. So that's going to be negative 13 plus 8. So that's negative 5. And then the last one is negative 18 take away negative 13. So that's negative 5 again. What do you notice here? They're constant. The first difference is the same. It's negative 5, negative 5, negative 5, negative 5. Okay? So I know it's linear because the first difference is constant. When you're doing this, if you notice that your first difference is not constant and you know that your equation is linear, go back and check your work. That means you've done something wrong. We're expecting this because we know that the equation is linear. We know that it's degree 1. Are we good with that? Okay. Now, another thing that we have to do is we have to try to graph. Okay? So we're going to graph it. What is this?
Excuse the interruption. Just letting you know, Sage Electric is in the building today doing their annual fire inspection. Please disregard any alarms you hear. Thank you. It's only a test. Thank you.
You had the whole week to do it. All right, so if we are going to plot this, remember x, y, right? X, y, that means my first point is 0, 2, right? So 0, 2, that's 0, 2. So that's where my first point is. My second point is 1, negative 3. So I go to the 1 on the x, then I go down to negative 3. Then I go to negative 8. Looks like I'm not going to be able to fit more than 3 points. 3 points is enough for me to know that it looks like a straight line.